Hello, my name's Bob Willis and welcome to Defect of the Month. Every month I provide or comment on a specific defect, and hopefully that's providing useful information to engineers to pass on to their colleagues, or hopefully to illustrate a particular problem and hopefully a solution, possibly to your customer, your quality department. So what I'd like to talk about this month is ultrasonic cleaning damage. If you're cleaning printed circuit boards, one of the options is using ultrasonic cleaning. And ultrasonic cleaning is extremely effective in improving the cleanliness and cleanliness performance when you're cleaning flux or other residues from a PCB. There's long been concern about the potential for damage due to ultrasonic energy, and that's particularly true on components which are ceramic based with internal connections, so basically wire bonds. We've also seen it on other fragile parts. Now, over the years there's been lots of controversy, but work done by good friends of mine at Hurst Research back when I was working at GEC Marconi, they demonstrated that if you used standard ultrasonic energy, if you did not clean for hours and hours and hours, then ultrasonic cleaning was extremely effective and did not damage parts. There was a report issued and it was well received in the industry, and in fact my friends were invited over to the US to give presentations to a variety of different departments, the government, and of course other research establishments, and they demonstrated that this really wasn't an issue. However, if you did clean for hours and hours and hours, and if you used ultrasonic energy which was much higher than the norm, then potentially damage could occur. But we're talking about cleaning typically within 2 to 5 minutes using ultrasonic energy, and this can be done in aqueous solutions and obviously solvent solutions, but it's been proven that it's extremely effective. Now if we just look at some of the other historical information, so this is an example of the report that was originally issued and in circulation at that time. Here's a couple of examples of test boards that I created again when I was a junior engineer, and it's a simple example of a board with flashing lights. I subjected this to ultrasonic cleaning and then tested it afterwards, and I also ran it with no caps, so I took the tops off the components so they weren't sealed anymore, so the ultrasonic energy or the liquid with ultrasonics on was actually in contact with the wire bond, so the worst possible case. And again, I never saw any issues understanding cleaning cycle times or lengthening those times to double and triple the times. So going from perhaps say 3 minutes to 9 minutes and or 5 minutes to 15 minutes, never saw an issue on any failures whatsoever. Now these examples do show failures. So failures first of all of components where we're talking about extraordinarily long cleaning times, which are just not representative of the industry, and an example of surface mount and also some wire bonds. So I think that if you look at the data that's out there, in realistic terms, there really hasn't been, and I've never personally experienced real failures with components in manufacture today. I have been shown, and we did see this in the research in the early days, again on testing ultrasonic energy, where again we're talking about hours of cleaning time, or the frequency used and the frequency ratio of volume of liquid was extraordinarily long or extraordinarily high. You could actually see the effect of cavitation taking place on solder joints, and these examples are indents, if you like, or voids in the solder, which was specifically created by that process, which was not representative of today or yesterday's technology. Thank you very much for watching Defect of the Month. My name's Bob Willis, and hopefully you've enjoyed an insight into perhaps not defect in this particular case, but a concern that people have had for many years, which hopefully has been solved.